Hey everybody, this is Chris with Overclockers Club. We've got a cool cooler from Cooler Master. Today we'll be looking at the PL360 Flux, but they actually have a 240 millimeter variety as well as a 240 millimeter all white, the white edition. And there's actually a white edition of the 360 and a 30th anniversary edition too, but today we just have the good old standard PL360 Flux. The Cooler Master website has a ton of information about the cooler, and we'll get to that here in a little bit, but first I want to look at the box and see if there's anything interesting, anything stands out. So the front, there's not a lot going on other than you can see that there are 3 RGB fans. There's some RGB effects going on with the pump. It says there's a controller included for your RGB, of course. Let's see, on this side we've got RGB addressable Gen 2 RGB, certified compatible with the Asus Aura Sync. There's Gigabyte RGB Fusion, MSI Mystic Light, and the ASRock or ASRock, or however you want to pronounce that, Polychrome Sync, so supports all of that. And let's take a quick detour to the Cooler Master website and see what they say about the product here. Premium dual chamber pump. That's really been around for a while. Cooler Master's been doing that for several years on their previous generations. But you can see how they're showing how the flow moves through the pump. Fine-tuned performance ratio. One thing you will notice here is the pump is shorter and it's smaller than they used to be. They used to be a lot taller. Let's see, the cooling fins inside. So underneath your base plate here, your copper plate, they've got fins that are machined into it. So what they've done is they've basically extended the height of the fins and then shortened or made the bottom there shallow, so that we're basically getting more surface area exposed to the coolant. And of course, more surface area translates to a more efficient cooler because you can remove more heat faster. Let's see, high-speed motor utilizing a ceramic bearing impeller, forces balanced water flow to and from the radiator, so that's good. Slim and sleek radiator. I didn't see anything out of the ordinary here on the radiator. They always do try to pack as many fins. They talk about, the fin density, but there's always a trade-off between packing as many fins in there as you can, and then you get to a point where you start to restrict airflow. So they've done some updating to the fan blade design. There's always a challenge there to move as much air as quietly as you can. So they talk about the airflow being higher here. So if we look at the previous fans versus the current ones, so we had 62 CFMs, and now we've got 72. So we've gone up a little bit there. And then the pressure that is generated, the air pressure, it's gone up too, although, that's a little hard to measure. Most people, you can't measure these things. And they talk about the RGB effects, which they are addressable. That's always cool. I mean, if you like RGB, it's great. If not, I guess you can turn it off. That's about it. So let's get back to the box. And checking out the back of the box, let's see, we've got the addressable Gen 2 RGB with the controller. So we'll use the Master Plus software for that. So that'll be something I'll have to download and get installed. Optimal efficiency pump, high water flow and pressure combined with quality copper base, enhanced sickle flow fan blades, interconnecting loop delivers high-speed performance. So we'll look at all that. Again, the website has a lot more information. English, performance, dual chamber, optimized flow and pressure. Okay, so we're talking about the pump. Superior performance ratio, combined copper base and micro channel to surface area refined for ultimate heat transfer. Of course, that's the whole game of cooling. Radiator fan enhancements. So we've got enhanced sickle flow fan blades, which with interconnecting loop delivers ultimate high-speed performance. Fan noise calibration, fine-tuned fan engineering produces optimized noise output. Dual loop ARGB pump lighting, addressable Gen 2 RGB ready for independent implemented customization. So I think that just means you can control the lights on the pump. So I guess really we can get it out of the box. So we've got the hardware bag. There's a lot going on there to cover all the sockets, and I'll go over the socket coverage here in a moment. There's the installation guide. Looks like it covers the 240 and the 360. 3 fans, 120 millimeter fans. Lighting controls, stuff like that. Connectors for your RGB effects. And oh, there's the controller, RGB controller. And here is the unit. You want to be real careful you don't, the fins on these are very delicate, so you got to be careful that you don't damage those because they bend pretty easily. All right, let me get that box out of the way. All right, so another thing you want to be careful, the copper here is fairly soft, so you want to make sure you protect that because anything that impacts it can leave a little ding or a divot, and you need that surface to be as smooth and flat as possible. And of course the plastic sticker here is meant to protect that surface, but you need to make sure that you remember to peel this off at the time of installation. So leave it on for now, but when you're ready to actually do the installation, you need to make sure you peel that off. It's easy to get all excited with the installation, and if you get in a hurry, it's easy to forget to take that off, and it doesn't work quite as well. Okay, so looking at the radiator, it has a nice, almost like a sandblasted finish. I like that. It's not glossy at all, and you can see it's got the, if you can get it right in the light, designed by Cooler Master. That's a nice effect. And you can see there's one fill port right there. These are usually blocked at the factory. That's where they fill the coolant in there, and it says warranty void if removed. So there's no reason you'd ever really need to get into that, but that's what that is. And another thing I always found kind of interesting, you know, if you look at the radiator, it's real easy to look at it and think that, well, all your coolant just goes one way, right? Well, it actually doesn't. It comes in, there's usually a baffle in here. So it comes in through one of these, and it travels. It's usually a 50-50 split. Sometimes it's a 60-40. There'll be a baffle, so the coolant will come in one side, travel down the length of one half of the radiator, makes a U-turn down here in the bottom tank, and then comes back. So your coolant path is actually double 360 millimeters. And when I get the thermal camera out, you'll actually be able to see that. And these are the new fans, the new design. It's actually got some weight to it. It feels a little heavier than a standard fan that I'm used to. So you got the usual 4-pin PWM connector there for power, and then you've got your RGB connector there for the RGB effects. Now these fans have some pretty heavy rubber insulators there on each corner. And then you notice the fan blades are not separate. They're all sort of connected through that outer, there's like a rim around the outside, and all the blades are connected. So you've got your manual and warranty information. Also in this bag you've got your 3-into-1, so 3 of your fans plug into these ends, and then this goes to the motherboard. So basically one fan header can control all 3 of your fans. A little bit of thermal paste. There's your LGA 2011 screw set, fan screws there to secure the fans to the radiator. And then we've got some more brackets here. So a couple different Intel installations in these in these bags. TR4, this is for your Threadripper AMD. Those things are huge. And then these are for your standard socket, your AM3, AM4, more legacy type of connectors there. So these are your bases. This is, let's see, LGA 1700. It's kind of hard to see there. And this one should be for all of your other Intel sockets. These are like your 1151s, things like that. So you need to make sure you use the right bracket for your particular motherboard. And that actually reminds me, socket coverage. Let me just push this up, and this stuff is on the box too, but your socket coverage, you've got all of your Intel sockets all the way up to the current LGA 1700. So that includes, if you go back to your LGA, 1150, 1151, 1155, 56, and then all of your AM sockets, AM2, AM2 plus, all the way up to your current AM4, and then your TR4. And as far as the RGB stuff, so you got a controller, you got some cables. These are basically the pieces that when you plug two connectors together, this pops over those connections and keeps them from pulling apart. There's SATA power for the controller. Here's a USB connector to go from the controller to the motherboard. And then you have this, and this is really what you would use. There's a lot going on here. So this end would connect to the motherboard, and then it goes up here, and all of these other ends here, we've got several. These would connect to your fans, and then basically the pump, so the RGB effects for the pump, so that you can synchronize everything together. Now there are two different ways that you can actually connect it. You can connect everything directly to the motherboard and let the motherboard control it. Or you have the controller here, and the controller again links back to the motherboard through this USB connection. And you can control everything through the Cooler Master software. So you have a couple of different options, and we'll explore both of those. And now we can take a real quick look. Again, this is the Cooler Master website and the specifications. The stuff that most people find important are things like, of course, we already talked about the socket coverage. Let's see, the other thing, adjustable Gen 2 RGB. We already talked about that. Oh, here we go. Fan speed, 0 to 2,300 RPMs, plus or minus 10%. So those fans will spin up to a pretty good speed. Airflow, we've got 72.37 CFMs max, 32 dBA on the sound. Pressure, we've got 2.96 millimeters of water. Fan life expectancy, over 160,000 hours. 4-pin PWM on the fan power. So 5-year warranty. That's another thing people would be interested in. And also here at the top of your specifications, you've got a downloads button. You can click on that, and you can see that you've got a product sheet, a manual, and the Cooler Master Plus software, and that's what I'll be downloading. Actually, might as well just do it right now. For Windows 10, Windows 11. All right, so a little later when I'm ready to install that, we'll get to have some fun. All right, so looking back at the radiator here, I want to measure the thickness, and these are all pretty close, but the way we'll do that, since my calipers, I can't really go beyond the frame, and the actual core is a little bit thinner than the frame. What I'll do here is measure these two little spacers, so they're 17 millimeters. We'll go ahead and 0 the calipers, and then we'll come in here and measure across those two. And since we 0'd the calipers, whatever this measures is the actual thickness, and I'm coming in at about 16.3 millimeters. Actually 16.18, so we'll call it 16.2. And we've got 12 rows here. So basically, like I said, there's a baffle usually somewhere in the middle here. So the coolant comes in one side, travels all the way down, and then makes a return trip all the way back. And it's usually 50-50, sometimes it's 60-40. And another thing to point out here, now the old cooler I took off, the cooler that I was using, you can see I need to get the thermal paste cleaned off of there. But if you look here, this mounting bracket that comes with the motherboard, this is pretty standard. There are some motherboards, not all, but some that benefit greatly from this little bracket. And this replaces, this is an aftermarket piece. These are about, I don't know, $10, $12. You take the old one off here, the OEM, the factory one off, and you replace it with this. And this is what holds your CPU down into the socket. Now it's a little less convenient because this is really easy to open up and take your CPU out. But if you don't really need to take your CPU out, which most of the time you don't, this is supposed to stiffen and help keep your cooler in contact more securely and more evenly, so that ultimately you get better heat transfer. Now I've heard somewhere around 8 to 10 degree benefits for some, and again it depends on your system whether or not one of these will really benefit. But I'm going to test the cooler without this bracket and then put this bracket on and see if this makes a difference. Now since we're putting this on an LGA 1700 socket, there's a special bracket here that has to be installed onto the pump. These guys right here. And the way the instructions recommend, there's actually a slot right here on the side of the pump, and this actually fits right into the slot. And if you notice, there are 2 tapped holes right here, very small, and they line up with those 2 holes right there and there, just like that. And then you use these 2 very small screws that are supplied in your mounting hardware to lock the bracket to the pump. So I'll do that on both sides. Alright, so everything is powered and running. I got to remember to peel that protective cover off of the pump. So we've got a lot going on here. The first thing is the actual installation of the bracketry was pretty simple. There's a little spacer underneath that you can see if I can zoom in on it. There are 4 of those spacers down there, and there's a nut that goes on top right here that secures this metal bracket at the 4 corners. But getting power to it is pretty simple. So there's 1 lead coming off the pump, and that typically goes over to one of the headers on your motherboard that will be called pump. And the next one over is the CPU fan. So this is the pump and the fan. And this adapter here is the 3-into-1. So all 3 of the fans over there come off of the fan header here for the CPU. And that gets everything running. Now the RGB effects, those go into this multi outlet adapter here. So all of the fans are plugged in there, plus the pump. So this other connector here goes over to that RGB adapter, and then that ultimately comes over to here to one of your RGB headers, ARGB. And that is how you get all of the fans synchronized with the pump, and that is controlled currently through the motherboard. And then after I show the motherboard controls, then we'll go ahead and plug this little control box in and show how this works. Now the other thing you need to do after you get your system powered up is make sure that your fans have been tuned, because every system, the fans run a little differently from manufacturer to manufacturer. Now pretty much every motherboard manufacturer has their own software, and MSI Center is what's used here for this MSI motherboard. You come over here to customize, and again it's different for every manufacturer. But you go to customize, and you scroll down here to one of your fans here. You click on the little gear, and you'll notice over here it says fan tune. And when you click that, basically what happens is your fans will speed up and slow down, and the system is monitoring the voltage so that it can generate a fan curve based on those fans. So you can see the RPM there will go to the maximum and then usually down to 0 if that's possible. And there you can see it generated the curve based on those fans. Alright, so the system is stressed using Prime 95. We'll go ahead and do some thermal imaging real quick so you can see what it looks like, how the heat moves through the radiator. Alright, so here's the thermal camera. You can see the top of the pump is relatively cool. You can see the coolant lines there coming out the side where they get a little warmer. You can see the VRM area of the motherboard is, of course, the warmest part. But when we come over here to the radiator, you can really see what's going on. So clearly one side of the radiator is warmer than the other. And there's a reason for that, which I was explaining earlier. There's a baffle here in the middle of the tank. So the coolant comes in on the left and travels down. So that half of the radiator, of course, will be warmer. And then it gets to the bottom, it does a U-turn, comes over to the right, and comes up the right half of the radiator. So ideally, the coolant coming in on the left should be warm, or at least warmer than the right. So we're coming in around 34 C. And again, this is the temperature of the tank, not the actual coolant. But when it leaves on the right-hand side, you can see it's a few degrees cooler, which is what it should be. So that gives you an idea of how these radiators work. So the way I'll do this, I'll use the software here that comes from MSI. There are basically canned tunes. There's a silent, a balanced, and an extreme, and each one has different settings with different purposes in mind. So silent, for example, will keep the fans as quiet as possible, and that usually means you run in a not really much of an overclocked situation. In fact, it usually underclocks a little bit to help keep the temperatures down. Then there's a balanced mode and extreme performance, and there's actually another mode here that I can go into called game boost, and I'll run it in that mode too. And I'll do all that with the standard bracket on the motherboard that I showed earlier, and then I'll disassemble everything, and we'll go ahead and we'll put this mounting system, or this bracket system on there. Actually, it's a CPU retention bracket, but we'll put that on there and see if it makes any difference in the temperatures. All right, so I collected all the data after running the silent, balanced, extreme, and the game boost testing. So next, I will take everything apart, get the factory CPU bracket out, and put this one in, and then I'll run the same test and see if the numbers look any different. All right, so there's the new CPU bracket installed. There's the old one that's been removed. So I reran all of the testing that I did earlier, and I really didn't know what to expect, but what I've got here, so here's the testing with the old bracket, stock bracket, and then here's the testing with the new bracket. And where I see a difference here is on the game boost and the silent, I actually got better numbers here with the new bracket. So silent, we went from 62 degrees Celsius down to 55, and then we went from 90 to 84, which I would call that a noticeable or measurable difference, significant difference. But on the balanced and extreme between the two, with and without the new bracket, the numbers really didn't change. They're pretty much the same. So I'm not really sure why. I really would have expected to see an across-the-board difference, but I don't. All right, so the next step will be to disassemble everything here and get this reinstalled in a system build so you can see what this looks like in a CoolerMaster case. Now, if you recall earlier, we talked about the two different ways you can control the RGB effects, and that means you can either control it directly from the motherboard, which is the way I have it set up right now, or you can use this little controller. So if you use the motherboard to control the RGB colors, and you can see everything is green right now, everything is synchronized. The motherboard, the pump, the fans, even the graphics card here, they're all synchronized because I'm using the Mystic Light software here, and this is part of the MSI motherboard software package. And this allows you to link all of your components together, or I can unlink them and control each one independently, but I have them all linked or synchronized right now. And I have it in the CPU temperature mode, which means right now there's no load on the system, everything is cool. That's why you see the green color there, and I can actually come in here and change what temperature that the colors change. So we've got basically green into blue into red, of course red being the highest temperature. So right now with no load, again, everything is green. But if we were to put a load on the system, and I am in, actually let me go back here to the user scenario. Let's go to silent mode, which will be the least, so we really shouldn't see much of a color change here. So we'll go to torture test and put a load on the system, and let's see what it does to the colors, if anything, here. So again, green is the coolest, and as things warm up, it should move into a shade of blue. So it doesn't look like we've got too much of a load on the system. It's not really changing. So let's move over to the balanced mode, and we should see things change to more of a blue. All right, it took it a couple moments for the heat to build up, but it did move to more of a light blue color. And then if we go up to the next level, you'll see the temperatures change. So it goes into a purple and then into a red because the heat is building up in the overclocked mode. So with a load on the system, you can see it goes up pretty quickly. So it's nice to be able to glance down and see right away what the temperature of your system is. So go back to the silent mode, and you can see the temperatures go right back down. Now back to the Mystic Light here. If we go ahead and switch this over to the standard rainbow mode, hit apply, it takes it a moment to change. It usually flickers on and off a couple of times before it switches over to the mode, but there we are in the rainbow mode. So you can see top of the pump, the motherboard, all of the fans, and the graphics card are all in the rainbow mode. Now if you have a system that cannot use motherboard controls, then we have this controller. So let me get this hooked up. So I've got the 3 fans plugged in here, and usually you want to pay attention to the order. So if you've got, let's just call the top one here fan 1, fan 2, fan 3. Well, the positions here you can see are 1, 2, and 3. That's if you're sequencing the fans, so that if you're in that mode, you're sequencing them in order. So you want to pay attention to that. This is the SATA power coming in. This is the USB connector that goes out and connects right over here to the motherboard header for your USB control. Now that I have that hooked up, since we're going to be using this Master Plus software control from CoolerMaster, I don't want it to fight with the Mystic Light control, so I can disable that. Sometimes these software packages will fight for control of different components, and you can run into problems. So it's best to disable, or sometimes you have to actually uninstall them in order for things to play nicely together. I don't know that that's the case here, but for now I'll just turn off Mystic Light and get this Master Plus software installed, and we'll see if there are any issues. And when you do the installation of your CoolerMaster software, don't be surprised if you get a little notification that there's some stuff that needs to be updated in the process. So it looks like it's actually rewriting the firmware. So first thing I did was hit connect, and then I wasn't sure, but then I realized I had to hit the program button, and it erases and then it rewrites. So it looks like it's just a firmware update. Okay, so there's a lot of different functionality. You can actually use this to control your entire system depending upon what components you have plugged in. Now I'll actually be mounting all of this into a CoolerMaster case, so we'll see how well it integrates. But for now, we're just going to focus on the lighting controller, which is the little box that we installed earlier. So right now you can see it's just sort of cycling through the colors. But I can control all that right here. So for example, if you want to go with a static color, if I pick blue, for example, and everything is blue, I can pick red, green, or really any other color you can imagine here. I can click on the color wheel here and just go through all different colors. So that functionality again is controlled over here. You've got all these different effects. Here's demo mode, for example, and it sort of cycles through different functions. You've got a lot of different effects here. What's interesting, you can actually turn it all off altogether, so I can hit that and no lights at all. But there is a multi-layer mode here, and what that does, remember earlier I showed you that you can plug your fans in a specific order, so you want to make sure that you do that. if you're going to do any sequencing. So right now all of these are set to rainbow, but let's say I pick this middle one and just set it to static, and you can see the top fan and the bottom fan are color cycling, but the middle fan is solid, static. It doesn't change. Let's see, I'll bet I can pick, let's see if I pick blue. Yeah, so there I can pick blue or red. So I can change the functionality of any fan that I want. So we can make that one recoil, make this one refill, and make this one, we'll just leave it at rainbow, and you can see that the fans are all sort of doing their own thing. So anyway, if you want to do all that, you can do it here from within these controls. Actually, if we want to reset, and that just brings it back to normal. All right, so now we'll do a system build, and this system is different than the one I tested on earlier. The one earlier was on an MSI Z790 carbon motherboard with an i9 13900K CPU, so a different animal altogether from what this one is. This system that I'm building in the case is an MSI Z690 carbon Wi-Fi motherboard with DDR5 memory. The CPU in this system is the i7-12700KF, so a notch or so below the 13900. The cooler is, of course, the Cooler Master PL360 Flux. The graphics card is the NVIDIA RTX 4090. Memory is the Kingston Fury Beast 32 gigabytes. Power supply, the CoolerMaster V850i Gold. The case, of course, is the Cosmos C700P Black Edition with Windows 11. All right, so we're back to the case. I've got the mounting bracket, as I trip over things, installed. So now I just have to figure out, do I want to put the cooler in the top of the case or in the front? All right, so I sort of been test fitting the cooler, and it seems to fit best in the front. So I'm going to put it in the front. I need to flip the fans around to get the wiring to come out on the opposite side, but I'll do that here in a little bit. So right now it's just loose in here, but it just seems to fit better. It seems to look better. A lot of it depends on how your tubes here want to naturally bend. You know, sometimes you can put it in the top, and the tubes, depending upon the orientation of the pump, just have a natural curve to them, and you're not forcing anything into position. And one thing I'll mention briefly here, and there are videos out there that go into a lot of detail, but they talk about how to mount the radiator relative to the pump in terms of the height of the tank, and what you're trying to avoid is cavitation. Cavitation is when you get an air bubble that gets sucked into the pump, and the impeller is just spinning in that little air pocket, and you're not moving any coolant. And let me back up a little bit. There will always be a little bit of air in your tank, in your cooler, and that's normal. You have to have a little bit of room for the coolant when it expands to expand into that small volume of air. Typically the volume of air is small enough it doesn't cause a problem. I've had a couple of systems over the years that when I'd turn the computer on, you would hear a little bit of slushing around or a gurgling sound at first. I never had a problem with them as far as cooling issues. But you can watch those videos that talk about this and the philosophies behind why it's best to mount a tank in a certain position. And you can come to your own conclusions, but I've never had a problem. So we'll see when I get this installed, but I really don't anticipate there being any issues. So I will get this mounted, and then I'll get the fans flipped over. And actually, not only do I have to flip them around so the wiring comes out on the opposite side, but I have to actually put them on the front. I had them on the back of the radiator before, and that would not have gone too well because I would have been pushing air out of the front of the case. I suppose it would have worked, but you don't get to see the RGB effects if the fans aren't on the front. Now, some people will mount their systems and add a second set of fans in a push-pull configuration, and you can do that. But the systems that I've tested that way, with and without the push-pull, there is a cooling benefit to the additional fans, but it may not be as much as you think. At least the testing I have done has shown it to not be a huge benefit. In fact, it's more of a hassle because of all the extra wiring and the extra headers that you need to plug the fans in and all that good stuff. So it's up to you. If you've got some extra fans and you want to use them, well, why not? But like I said, don't go into it expecting a huge cooling benefit. Plus, with double the fans, you get more noise too. All right, so I'll get all of these tightened up. And another thing to mention, the way I'm mounting these fans now, the fans are on the front of the bracket here, and the radiator is behind it. So the screw is going through the fan, through the bracket, and into the threaded holes on the radiator. There are several different ways you can do it, but if you do it this way, keep in mind that the screw is basically pinching the fan, so you don't want to be torque happy there and really tighten these down, because you're bending the ears, and you can actually break them if you tighten them too much. So you just want to be careful, snug them down good, and just give them just a little bit of a turn, and don't go crazy on the torquing. Again, that's just for this particular way that I have it mounted. And the system build is complete. Again, this is the CoolerMaster Cosmos C700P Black Edition. There you can see the pump, and the radiator is in the front, and I could have very easily have put it in the top, but I actually like to show off the RGB effects. I'll just take this off, and the case looks fine actually without this front panel, but if you really want to show off your RGB effects, that's the way to do it. And they would look fine on top also, and I may at one point add some RGB fans to the top. But those two fans that you see right there, the two 140s, those were actually the fans that came from the factory in the front, so I had to relocate those to the top to make room for the RGB fans. But overall, that cooler looks right at home in this case. Now, if you want to see how this cooler performs in this case, you can check out the case review. I'll have a link to that in the description, and you can see how it handles the heat. But basically, it does a great job, and the fans in the case, the way I have them, also did a good job of keeping the heat down. So overall, the PL360 Flux, I think, is a decent cooler. You know, you throw it up against a processor like the 13900K, which is capable of bringing pretty much any cooler to its knees. You know, you go crazy with an overclock, and all you're going to do is bounce off the thermal limits, and it starts to throttle back, and what's the point? So really, unless you're just stressing your system to the limits, benchmarking all the time, this cooler will be just fine in a daily driver system or a gaming rig. No problem at all. You know, and really the 13900K, I'm not aware of any cooler out there that can handle everything that a processor like that can throw at it. So I do think it is a decent cooler, and right now on Amazon it is showing up for $179.99. And what is interesting is right now the PL240 Flux is showing up for $10 more, $189.99 on Amazon. And I do have one of those to review. And I just checked Newegg, and the pricing is the same, $179 for the 360 and $189 for the PL240. It does seem a little strange that the smaller cooler would be more money. It's usually the smaller cooler is a little less, but who knows why. Anyway, they do make the 360 and the 240 in the white edition, so we'll be reviewing these coolers here shortly. As for the MasterLiquid PL360 Flux, I would give it the Overclockers Club Gold Award. So this is Chris with Overclockers Club. Thanks for watching, and don't forget to subscribe.